So today we will be going through part 2 of chapter 3. So we'll be going through methods, inheritance and exceptions as they relate to classes and objects. The last presentation was on the first half of this chapter, which was basic concepts of object-oriented programming, the differences between procedural and object approaches using the good old stack as the example piece. And then we went through the properties, which are basically variables and attributes associated with classes and objects. So, kick off with methods. So, the method is a function embedded inside a class. And the naming convention is pretty strict in what they do. So you've got to have one parameter, and it's convention to have it named self, just to be interesting. So you can put extras in afterwards, and they should be separated with a comma. Now, this allows you to specify other parameters when you invoke these actions later. But we need to get through and realize that the self parameter is used so that the object's instance can access the class variables, and we can invoke these objects and class methods inside the class. So a good way of doing this, well, basically the only way of doing this inside, is to follow the naming convention like we do with the init value. So when you use the regular naming conventions, you need to provide the self parameter for the constructor. It needs to be the first one. You can add more in, and you then can use this to set up objects from it. Now, this will become clearer when we get stuck into actually doing some of this. So, when you're doing work to try to manipulate the data that you run through these methods and the constructors, you can use the same methods or tricks, if you like, that you do with any other part. So again, if you use a double underscore at the start of the name, it's a private name. So there are some that are built in to every object, and they are dictionaries and name. Okay, so the dictionary gives you properties that are associated with the class or object, and name returns a string value that you can use to print the information on. Now, please note the name is only inside the classes. It doesn't get duplicated out to the objects that it's created. So some of the other properties that we can get from these objects and classes is by using type function, which will find the class which has been used to basically create the object. Another one that you may want to use is module, which is a string and it stores the name of the module which defines the class. Bases is a tuple which gives you the classes which are direct superclasses for the class. So remember, tuples you can't edit. It's just basically a data set that's fixed. So this is a good way of getting the core information about your associations. So when we're dealing with methods, we basically do two things with them. With introspection, we get the ability to examine the type and properties of the object in runtime, while reflection allows us to manipulate the values and properties of objects at runtime. So they're the two activities that we tend to have. Now, as I said, these methods in relation to classes will become clear when you go through and work your way through them. To that, there are 4 labs that are associated with the methods section. So the timer class, days of the week, points of a plane, and triangle will take 30 to 60 minutes each to complete, depending on your typing speed. Now, these will help cement that theory that we just went through. I know it's a lot to take in initially just on the theory, but by actually working your way through these labs, the associations and become clear. So the other thing that it'll help reinforce is how we invoke methods and functions from classes, modeling objects and things like that. So please make sure you go through. Now, inheritance. This is fairly straightforward, but can get a little complex. There is a default string method that returns previous string, which can be used to get information from within our classes into a format that we can use. Now, we can redefine any of the default methods or functions that are built into Python and customize them by using the same name. So when we want to do certain things, we may need to redefine base instructions that come with Python. So when we inherit properties from a superclass or a class into objects or other classes, we are passing on all the variables that exist in the parent. So when we create another class, it's called a subclass, and it has the properties from what it's known as the superclass. This, in turn, is exactly what happens when we create an object. The object inherits the properties from the class. So by adding different classes, if you like, together to create a new one, we can build the resulting class that inherits properties from its building blocks. So we don't have to rebuild everything from scratch. So we don't have to keep redefining functions we want to use over and over again. With careful planning, we can put those functions or methods into a class, and then when we derive a subclass or an object from it, they are inherited as part of the process. So if you cast your mind back, you'll remember this little image. So this is to highlight what we're talking about with the inheritance and different levels of classes. So Python works from the bottom up in as far as tracking itself. So when it comes to finding methods or properties, it starts from the bottom of the inheritance tree. So it will come up, for example, tracked vehicles into land vehicles, and then up to the generic superclass of vehicles. Now, every class or subclass created will inherit all the properties from the parent that it's created from. So you can have multiple levels of inheritance, and in this example we only show a single inheritance. In other words, we're inheriting traffic types, if you like, from the previous instance. So for wheeled vehicles, its superclass is land vehicles, whereas land vehicles has a superclass of vehicles. And land vehicles is also a subclass. So in this example, land vehicles is both a superclass to those classes below it, and a subclass to the class that it is below. So we reuse the same terminology. It's just how we apply it. It's fairly important that we identify the relationships between classes, and we can do that with isSubclass function. So this expects two parameters, which is the two classes that you're comparing to each other. It will return a true or a false result. So if class 1 is a subclass of class 2, it's true. Otherwise, it's false. So using this in a loop, you can work out your relationships. IsInstance is the same type of idea, but it works with an object. So we're trying to find out whether an object is a member of a particular class. So again, two parameters, the object we're comparing and the class we're comparing it to. And this will return a true if the object was derived from that class. Another one to be introduced here is the is operator, which checks whether two variables have the same source. Now, objects are uniquely addressed each time they're generated. So when we create objects and they're the same object, because we've given them different variable names of the same object, we can refer back to the same unique ID, and this is what the is function is checking. So object 1 is object 2 is saying, is the unique code that identifies the object the same in both objects? If it is the same, then it returns a true. Now, these variables are not referring to the object themselves, they're referring to the handles of the objects. So they're identifiers. A string is a variable, but if you use this function on two different strings that contain exactly the same information, it will be false because each string value is not the same object. There. Alright, so there's a clear definition here that we are looking for objects, not necessarily the contents contained within the objects. So something we kind of need to get our head around. When we inherit information, the order of inheritance is important. So when we set out our code and we create classes of different levels, so we create subclasses, as in the example here, we are level 1 and level 2. Level 2 is a subclass of level 1. They're both using the same variable, var. The last instance being created is the one that is the value used in the same variable. Okay, so here we're saying var equals 100 and here var equals 200. Just like you do in a null variable situation, if you have it listed in line 12 and then you redefine it in line 20, line 20 is the latest definition and holds the latest value. The same occurs when we inherit properties from classes and we have the same variables, they will overwrite. We can inherit from two superclasses, and we do this by having them listed in parentheses separated by a comma. So class sub is going to inherit information from left and right classes. So this information and this information will be part of the sub. But the order that we have the names listed in the parentheses is important, because it comes down to the order process that Python uses to create its objects. So when it's looking at its parts, it looks at the object itself, then its superclasses from bottom to top. So it works its way up towards the top of the tree. If there's more than one class on the same level, like in this situation, then it reads them from left to right. So when we have a look at fun, it is in both of them. But because we're inheriting both left and right at the same time, it's going to read left first, but right is not going to overwrite any values that are duplicated. Now, it's a little strange and takes a bit of getting used to. So, when we go through and modify the behaviors that we inherit, it's called polymorphism. So this is a method that we can modify the outcomes in subclasses and objects, and when we do it with our class bases, it's called virtual. Now, the idea is to place any code that you want to reuse in all of different subclasses, rather than having them, repeated in each class. We put it up the top in the superclass, and that then is inherited into all of its children, and this helps keep your code clean and consistent, and it puts a single point where you can modify the behavior, and it'll update across all of its subclasses. Next, the composition of how you structure your classes is pretty important as well. So when we compile objects, we can give ourselves a composition of desired traits. So think of it as building blocks to create a structure that will deliver the results that we're after. So by using these inherited structures and capabilities, we don't have to reinvent the wheel. We can just modify it to make it suit the requirements that we want. So consider the composition projects as a container that's able to store and use the objects within itself. But be careful, because this little thing called the method resolution order is the law. It cannot be bent, violated. It is and always will be obeyed. Now, what is the method resolution order? This is the way in which Python scans through the class's hierarchy to find the methods that it needs. If you call or try to force inheritance that violates the MRO, it will generate a exception, strangely enough. And look, that kind of led into the next topic. Alright, so I won't go through all the try except details again and various bits. I'll just tell you that we can expand on this. We can add an else statement. So we can expand on our exception handling. And the other one we can use is finally. So else will only be used in the condition that the others return a false. So its exact use is like it is in the if statements. It'll try this, else it'll do that. So that's normal. But finally is always executed, and it must be at the bottom because of this. No matter what happens with the error handling in the upper try exempt block, the finally branch is executed regardless. Now, why would we want to use these? We can provide ourselves with more detailed information on our exemption handling. Now, exemptions can be classes. Surprise. So when an error is raised, the object is created. So we can go through the branch and expand the accept function with the as keyword. So this allows us to identify the exemption as an object and provide a more robust analysis of the exception. This is it as far as its execution. So it goes through the accept branch and it doesn't go any further. So it goes back to normal programming afterwards. It's there to provide us with more details of the exemption and provide us with the ability to delve deeper into what has occurred. Now, just for fun and giggles, you can actually create your new and personalized exemptions as subclasses of the predefined exemptions. So it has to follow the same rules as a normal subclass, but Python's very interesting. You can actually build your entirely own hierarchy of exemptions, but you've got to fully build it. So because it's like the tree structure that we've been seeing with the superclasses, subclasses, exemptions use the same hierarchical approach. So you can create your entire exception environment to handle situations that you wish. I'm not going to go through all the lovely syntax of it in the PowerPoints because there was just several pages of examples given and talking about individual elements and how that works. Just know the core is as they are and follow the hierarchical approach. They can be defined as individual classes and subclasses. So it's fully customizable to your requirements. So, in summary, in this presentation we went through the methods, which are available in class and objects, constructors, parameters, and the various properties inherited. So next we looked at how we can use the inheritance functions and create our own individual structures based on the building blocks that we derive our inheritance from. It allows us to pick and choose the properties and the methods that we inherit and create a new function, if you like, from those inherited properties. We then had a look at how exemptions handling can be increased in scope by using different command structures. We've expanded the try exempt branch methods to include 2 new branches. And we also explored the concept of expanding and creating our own exemptions so that we can be very precise and get error messages and handling of those messages customized to the way we wish to handle them. So that's enough for this chapter, and I'll see you in the next one.